Welcome back. I'm Mike Casper. I am the lead instructor and co-founder of MTI DTC. And this video series is going to cover some MIG welding. MIG welding is a big old umbrella. There's a lot going on with MIG welding. You can change the wire, you can change the gas, you can change the deposition rate, you can do all kinds of stuff. So we're going to keep it very simple. We're going to do a short circuit mode, which means that the wire coming out of here will hit the steel, it'll create an arc, and that wire will melt into the puddle, okay? So let's start off by talking about some differences that we have between stick welding, which we covered in the other video series, and MIG. So in stick welding, we're in charge of the arc length. It's changing, ever changing the whole time we weld, okay? So this is called a manual process. This, you push the button and the wire comes out. So you're able to maintain the arc distance off there. So I pull the trigger and the wire comes out. The wire that's this coated with the flux is exactly like this wire, okay? It's the same composition, 70,000 PSI. This is 70S wire. S means solid, okay? So we'll cut him off. So this wire is a solid piece of 70,000 PSI material. It's 0.35 in diameter. So when you weld with this, you have to make sure that everything is coated 0.35 when you weld with this. There's a spool of wire underneath this box back here, okay? I'm not gonna get into machine setup too much other than we need a wire speed and a voltage, okay? Those are available online through your Miller distributor, through your Lincoln distributor. There shouldn't be any really, voodoo magic on how to set up a MIG welder. It's all over the internet. It goes by material thickness, okay? If you're welding 3/8 plate, in this case in the horizontal position, or we call it flat, it's gonna tell you exactly where to set this to make the proper weld, okay? You might have to tweak it a little bit to your liking. Our employers pretty much tell our guys where to set the machines at because they want a production of a certain amount every time. So if you turn the welder down, you're gonna slow the process down and you won't be able to weld as many as the next guy sitting beside you or standing beside you. Also, and it's done out of position, so we talked about in our stick welding vertical up, this'll weld vertical up just fine. But we have to turn it down almost to the same parameters as what we stick weld with. So there's really not a huge advantage to weld out of position with this because the advantage of this thing is it goes really, really fast, okay? It'll produce a big puddle in a short amount of time and we can get with the program, okay? This will only burn as fast as it'll burn. This will too, but it's a lot hotter and faster, okay? So with that said, we can't really, out of position, overhead, vertical, horizontal, we can't really speed that process up other than we don't have to spend time changing the rod. This wire is in this particular case, is on a 44-pound spool. So I can make a weld from here to the shop and back and go around the block and all kinds of crazy stuff, and I have to get my finger off this trigger. So I always enjoyed stick welding because I knew in about 35 seconds to 45 seconds, I was gonna get a break. This thing was gonna run out and I was gonna get to throw my hood up. Some of the welds that are around this area, it might be, you might be 15, 20 minutes with your hood down pulling this trigger. So anyway, it's just all part of the welding industry. So us lefties, we stick weld from right to left. Okay, we drag the puddle, so the puddle's behind us, so we're dragging it. With this particular application, we're gonna push the puddle. So I'm gonna weld from left to right instead of right to left. So it is the exact opposite of how we stick weld. So if I were stick welding this, I would start my stick on this side and weld across here, dragging this. So this, I'm gonna start on this end and I'm gonna push that puddle. Why? It helps with penetration. So we want to see that, we want to pound that wire into the front part of that puddle to penetrate the steel, okay? Again, penetrating is we're getting that base metal hot, we're replacing it and mixing it with the filler metal, and it becomes one. And so that's what we want to see when we weld. We want some penetration. Okay, so we'll get all set up here. As soon as this metal tip, I'm going to pull the trigger and we're welding. A lot of people think that this is easy welding. It's more simple than stick welding in one aspect. We don't have to have that arc length control. We can keep the arc length the same, pull the trigger and go. But it still takes some technical savvy to understand every aspect of MIG welding. There's a lot to it with the deposition rate and deposit. There's short circuit, there's globular transfer, which we don't use, and then spray mode. Spray mode is very hot, so you can mix up the different gases. You can MIG weld aluminum, you can MIG weld stainless. There's just a plethora of stuff you can do with it. So it's a very versatile process. And you know, once you understand how to weld the basics of it, changing gas or something might make it smoother on a particular base metal. But for the most part, MIG welding is you get your perimeter set, you get yourself comfortable, pull the trigger and go, okay? All right, so we'll get ready. All right, so again, I ate a banana for breakfast, so this is going to be a little bit crooked. My wire I'll snip off. So basically my parameters are set, and just for reference, I'll take a spin around here. And so we're on 24.5 volts and about 4.5 inches of wire. Okay, so that's our wire speed. Those are parameters. You can look those up. It's set pretty good for 3/8 plate right now. Kind of see that I got a little crooked going on because I just kind of wanted to save some room. The next weld, this is a bead. So when we did our stick welding series, that was just a weld bead I was putting down. So this is a bead. The next one I'm going to put in the corner. This is called a T-joint for obvious reasons. It's a T. Okay, you can do a T-joint. This is technically horizontal, vertical, overhead. Flat is when the V of the T is up like that. Us pipe welders, we call flat that position, technically horizontal. So I'm gonna run another weld here, and it'll be in this two pieces coming together. So if I'm stick welding, MIG welding, TIG welding, everything goes right in the center of that, you know, this is a 90 degree, everything, all the weld goes right in that 45, okay? All right, so we'll run another MIG weld through here. All right, so there's a decent MIG weld right there. It's a single pass. Again, we're looking for uniformity. We got our C shape going there, and we're hot and fast. That's probably twice as fast as I would go across there with the stick weld. Same strength, same everything. So there's a lot of advantages to MIG. Some disadvantages is this heavy whip I got here. This thing's pretty cumbersome. A lot of times in the industry, they'll run these off booms and they'll come down so a guy doesn't have to hold this weight of this all day for an 8-hour, 10-hour, 12-hour day. It's not real portable. So if I had to get up on a ladder 20 feet up in the air in a pipe rack, this is probably not something I would grab. I would grab a stick welder. The versatility of it comes in, we can turn it up hot. I can work off this bench really quick. I can weld thinner material with it. I can turn it up and get going. So a lot of pros and cons to what you're doing. I use it primarily at home on my cars It helps with sheet metal and things like that. You have to put a series of tacks around a piece of sheet metal. You just can't start welding it. You'll warp the daylights out of it. So it's got its perks for sure. Okay, time and a place for everything. Doesn't like the wind, rain. Doesn't like to be outside. All that good stuff. Stick welding. It really, as long as you're keeping it dry, the wind doesn't affect it too much, and all that stuff. So position-wise, like I said, it will weld uphill. It will weld overhead, but for the most part, it's turning it down pretty low to where that speed advantage is not really twice as fast. You know, it might be, it's faster in the fact, like I said, that you don't have to change your stick, but it's just, you kind of got it, you're still combating gravity, still heat, and all that stuff, so we got to turn down. Anytime you get out of any position but flat on MIG, you're definitely going to have to start cutting that voltage down, and in turn you cut the wire speed down, okay? So I know we didn't touch too much on the machine, but it's either running or it's not. There's a lot of moving parts to this thing, and I'm not going to cover all those right now. So this is the flat position MIG. We ran a bead, really nothing to it. This would be a good place to start with your parameters, and then we went in with the weld. We actually welded these two pieces together. This is the T-joint. We just put it right in the center of the 45 there, pulled the trigger, and went across there. Again, that's the flat position. If you wanted to go to other positions, try it. Start, you know, again, this will weld downhill. It's not something that you would use for penetration-wise. So we like to weld it from the bottom to the top. Our overhead is overhead, horizontal is horizontal. So, you know, you're trying to get your heat and your wire speed together with your travel speed to make a decent looking bead. If it welds like this in the flat, it should look very similar to that in the vertical. It should look very similar to that in overhead. So that's our flat position, and we'll go on to the next process in the next video. Thank you.